distance word problems. What I want to point out about this is what we're really learning to do is analyze the word problem itself. You guys already have all the skills you need to actually solve them. What's tricky and what's new is taking the word problem and putting it into an algebraic form. Once you've got it in that algebraic equation, you can solve the equation. You have all the skills you need to solve algebraic equations. But how do you get from the words to the correct equation that actually represents that problem? I have my problems here, but I seem to have, here we are. All right. So problem 1 we're going to look at today is this. Jake is flying on a plane from Chicago at 400 miles per hour. John leaves on another plane 2 hours later. From Chicago. Flying, leaves Chicago, sorry. Flying in the same direction. At 600 miles per hour.
Those are fast bends.
How long will it take John to catch up with Jake? All right. So what I like to do when I see word problems is kind of look at all the numbers in them, because that typically is the stuff we're going to turn into algebra. So the first number I see here is 400 miles per hour. What is that? If you were to describe 400 miles per hour, it's an example of what? A speed, yeah. And what have we been calling speed? Instead of speed, we've called it
Rate.
rate.
Rate could have been kept somewhere.
Use this.
Thank you.
So this is a rate. Then it says John leaves on another plane 2 hours later. What is 2 hours? What is that telling us? 400 miles per hour was a rate. 2 hours is
Time.
a time. Yeah. Now, I want you to read this sentence again and tell me, who is traveling for the longer amount of time? Who's traveling for more time? John or Jake?
Wait, what's the question again?
Who's traveling for a longer period of time?
Where are we going to?
Yeah, that would make more sense if we knew where we were going.
Doesn't matter. Who's traveling for a longer period of time?
John. I mean, me.
Yeah,
Because he's going faster and he'll
because
catch
you
up with me.
leave first, right?
Yeah.
He leaves 2 hours later. So he's traveling for 2 hours less than you. You're going for 2 hours more than him. Okay, and then it says 600 miles per hour. That's an example of a what? Rate times distance. Yeah, that's another rate. And then the question, how long will it take John to catch up with Jake? When will John catch up with Jake? What is true about that? If two things catch up, this is where this problem is different from the ones we looked at yesterday. Yesterday you looked at two people leaving from the same point, going in opposite directions, or two people leaving from opposite points and meeting in the middle. If I were to draw a diagram of what's happening in this problem, we have one person leaving, and then a second person leaving, and we want to know when have they traveled the same distance? When has John and Jake, when have they both gone the same distance? So catch up or overtake or pass, any of those words, they really mean same distance. Okay, so what we're asking here is, when have John and Jake both gone the same distance? Here's Jake leaving, going here. Here's John. How long does it take distance 1 to be the same as distance 2? So I'm going to create my little chart, rate, time, and distance. Rate times time equals distance. All right. I have Jake and I have John. What can I fill in on this chart? Well, it's pretty easy to fill in the rates here, because it tells us Jake is going 400 miles an hour. So that's Jake's rate. John is going 600 miles an hour, so I can fill that in. The time is a little tricky, but we know that we're looking for time. So time has to be our x. It's unknown. We don't know the time yet.
But John's would be.
And we know that one time is 2 hours longer than the other time. So I could write one time as x and one as x plus 2.
Yeah,
Which
John's
one is
would
going to be x and which one is x plus 2?
John's would be x plus 2.
So you're saying if Jake has gone x hours, John has traveled for 2 more hours than Jake.
Oh no, I would be x plus 2 because
Yeah.
I've been doing.
This is the trickiest thing about these problems. Okay? It always looks like, because it says John leaves 2 hours later, it always seems like then John is going to be x plus 2. But think about it. That means that Jake has already been traveling for 2 hours by the time John leaves. So John is going for x hours. Jake is going for that time plus those 2 hours that he already spent in the air when John left. So if John leaves 2 hours later, Jake's time is x plus 2. John's time is x. Now to find the distance, I know that rate times time equals distance. So 400 times x plus 2, don't forget to put that in parentheses, is Jake's distance, and John is 600x. I don't need parentheses because there's just one term, so 600x.
But there isn't a total area.
There's no total distance. So these two things don't add up to anything. So how am I going to make an equation? And this is where this little diagram comes into play. What do I know? I know that Jake's distance has to equal John's distance. That's what I'm looking for. I'm looking for the time when they have gone the exact same distance. So I'm going to set Jake's distance, 400 x plus 2, equal to John's distance, 600x. I'm going to write a little note here. Set Jake's distance equal to John's distance. And I do that because, so you might add this to the note in your notes, I do that because it says catch up. So catch up, pass, overtake, those all mean distances are equal. All right, any questions so far? No? Now I just have to solve this. So I use the distributive property, 400 times x and 400 times 2. I get 400x plus 800 equals 600x. I'm going to subtract 400x from both sides. So that cancels out. I have 800 left over here, equaling 400x, or sorry, 600x minus 400x is 200x. And then if I want to find x, I divide both sides by 200. So x equals 4. Now I have to look back at the question. How long will it take John to catch up with Jake?
4 hours.
4 hours, right? Because x is the time that John is in the air. So it will take him 4 hours. If we write our answer as a sentence, it will take 4 hours. All right, questions on that one?
Do they ever win the play?
Did they ever win? That's a good question. I think what happens is once they catch up, they're sucked up into an alien spaceship. Like the Millennium Falcon brings a tractor beam.
I don't think the Millennium Falcon has a tractor beam. That's more of a Star Destroyer.
That's probably true. It might though. It's pretty big. It's a
But
freight
like,
train.
it's not enough to like hold a ship.
I'd rather be on the Millennium Falcon than the Star Destroyer.
All right.
Well,
So it
yeah,
takes
I
4
think
hours.
one would.
Can I erase this? We're gonna do one more problem like this together.
Okay.
Can I erase this one? Yeah.
Lego or?
A different
Do you
color.
want to, would you like to add that?
2 cars.
That's easy.
All right. Jax and Maddie leave school driving in 2 different go-karts.
We have a go-kart here.
Jax leaves first going 40 miles per hour. Maddie leaves 1 hour later, going 50 miles per hour. You thought Jax was fast.
Yeah, but go-karts usually go like 20 miles per hour.
How
Go-kart motorcycle.
long before Maddie passes Jax? Jax and Maddie leave school driving in 2 different go-karts. Jax leaves first, going 40 miles per hour. Maddie leaves 1 hour later, going 50 miles per hour. How long before Maddie passes Jax?
Where are they going to?
So if we were to draw a diagram of this, what would the diagram look like? Here's distance 1, Jax leaving school. How would I draw distance 2? Where would I put the arrow for distance 2? Yeah, underneath, going in the same direction, starting in the same place. What do you guys think? From Maddie.
Wait, can you repeat?
Is Maddie starting in the same place as Jax? That's
Yes.
the first question. So I'm going to start my arrow here. Is she going in the same direction?
Yes.
I guess so. I didn't actually say that, but it seems like it because she's going to pass him, right?
Yeah.
So she's going in the same direction. And what am I curious about? What do I want to know?
How long will it take before she passes?
Yeah, so again, I want to know when are their distances equal? So this is this type of a problem, right? They're leaving in the same direction, and I want to know when that distance 1 equals distance 2. All right, let's draw our grid here. Rate times time equals distance. This marker's dying on me. Ah, that one's already there, I guess. Let's put Jax up here. We'll just use a J and Maddie down here. What can I fill in?
You can fill in the rate,
Okay. What could I fill in for the rate?
40 and 50.
40 here?
Yeah.
Okay. 50 here? What else can I fill in?
You can fill in Jax as x plus 1.
Nice, because he left first, right?
Yeah, and
So
then Maddie.
he's traveling for a longer time,
Yeah.
and then Maddie's time would be just x. Okay, how do I always find the distance? What do I
Or you
always
put-
put
you
in the
combine
spots?
them.
Yeah, I multiply them. 40 times x plus 1. What would I get here? What's Maddie's distance?
50x.
Yeah, I'm multiplying, so 50 times x, or 50x. Now, how do I set up my equation here? What do I know about this?
90x minus x plus 1.
So, are you trying to combine the top one and the bottom one?
Yeah.
Is that what's going on here? Are we combining them to
No.
make a total distance? Not really. What's happening here? Look back at your notes for the last one.
We're using our whatever it's called, the rainbow. Distributive property.
Okay, we will have to use the distributive property, but I have to write an equation first. How do I write an equation from these two distances?
40 times x plus 1 equals 50x.
Yeah, how did you know that those would be equal? How come Jax's distance equals Maddie's distance? Why do I write that equation?
Because we're going the same distance.
They're going the same distance, right? I don't even care how far they go. For this type of problem, I don't actually have to know the actual distance. I just know that this distance equals this distance. They don't add up to equal a total distance, like the last set of problems we did. Instead, one equals the other. They're the same. That's the time that Maddie passes Jax. Okay, so now I can do the distributive property. 40x plus 40 equals 50x. How would you solve that?
Subtract 40 from both sides.
Subtract 40?
Subtract 40x.
I would subtract 40x from both sides. You could subtract 40, it might help you. But it's going to be easier if you subtract the 40x. So then we just have 40 equals 50x minus 40x is 10x. Now I divide both sides by what? What's the number in front of x? Divide both sides by 10. X equals 4. So what is my final answer?
Maddie will pass Jax in 4 hours.
Nice. Maddie will pass Jax in 4.
That's a long time to be driving. Well, yeah, no.
It's a long time to be driving in a go-kart.
I think the gas would run out. Because it's go-kart.